What is good, guys? Today we're going to talk about corrosion fatigue, but a review from yesterday, SCC, stress, corrosion cracking. That is when two things are affecting the corrosion. Metal being pulled apart, tensile stress is under tensile stress. Second thing is corrosive environment, salt water, acidic water. Okay, those things will eat up the metal. Today, corrosion fatigue, it's something similar where it's also two things that affect the environment. First thing would be a cyclic stress fatigue. Okay, something that gets repeated again, an oscillation, right? A pulse. Not one giant push, it'll like oscillation, right? You get it. And the second thing would also be a corrosive environment, salt water or acidic water. Okay, so when you think of cyclic stress, think of a car suspension, the springs in the car. When you drive along a speed bump or an uneven road, the spring will go from uncompressed to compressed. That's one cycle. Okay, when you think of fatigue, though, people usually think of mechanical fatigue where it's a paper clip bending back and forth like 8 times and then it snaps. That's mechanical fatigue. Corrosion fatigue is if you do the same thing to the paper clip back and forth, and dip it in acid at the same time. So that would really get the metal to corrode really fast and suddenly. Okay, so what are some prevention methods to stop corrosion fatigue? First thing would be material selection. Choose better materials, things like stainless steel has chromium in it, high performance nickel alloys, nickel better than aluminum. Second thing would be protective coatings. Use a high performance paint, use epoxies, use CVDs, chemical vapor depositions. Those things would keep corrosive chemicals away from the metal surface. Third thing would be cathodic protection. Add a zinc block connected to the material you want to prevent corrosion from, and the zinc block will get eaten up as a sacrificial anode. Fourth thing would be design changes. Stay away from sharp corners, stay away from crevices where water can collect, and that'd be good. Last but not least, environmental control. When possible, remove moisture and use inhibitors in the corrosive environment to neutralize that corrosive environment. Okay, so one more time in like sciencey terms, what corrosion fatigue is. That is when you have a chemical attack that creates tiny pits, giving the cracks a head start, but then the concentrate pushes the cracks moving forward. Okay, so let me actually pull up a visual for you guys. I guess I haven't done that in a while. 1 second. Oh, shoot. Okay. So here, oops, we have an SN curve comparison. Okay. We have number of cycles. So how many times it happens? Let's see, 10 times 10 times 10, 1,000, 10,000, 100,000, 1 million, 10 million, 100 million. Okay. That's an order of 10, magnitude of 10, right? Times 10. Stress amplitude is how high the stress would be. So when the stress is really high, it can last all the way to 100 million cycles. Okay, this is when the stress is like high. But you see, there's a line here. There's like a safety net. It'll never go below this line, so that means technically it can go forever. But we know that things will always eventually like fail, no matter how much cycles. And then that is when it's in air, just regular metal fatigue. When it's in a corrosive environment, let's say this is in the ocean, in salty water, you see how there is no safety net. So when the stress amplitude goes down, let's say there's almost no stress at all. Like let's say there's one, right? 10 times 10. Let's say this is 100. Let's say if there's one stress, like this is almost nothing. Like if I push it with my hand at 100 million cycles, it'll fail. Okay, it might not fail at 1,000 cycles, but yes, over time it will fail. So that's basically corrosion fatigue in a nutshell. Thank you guys for watching my video. I'll see you guys in the next one.